In this peaceful planet, plants make our Earth full of dynamic. Plants which grow in this planet are particularly interesting. Also, plants play an important role in providing food, oxygen, and habitats of animals. Plants are the home of animals, but what is the home of the plants? Obviously, that's the soil. And how does the soil affecting the growth of the plants? In this documentary, we are going to find this answer. Beautiful things are always around us, but we seldom notice its presence. Just like the garden near our campus, we never notice it's there. In this beautiful garden, it is easy to find out a lot of amazing things.
Hey, look! Do you know why the plants in this plant nursery are much more than this one?
Is it just a coincidence?
No, I think there must be some reasons.
So we can conduct an experiment to find out.
Then they started to investigate.
Is the difference caused by the level of sunlight? No. The locations of two plant nurseries are similar. They receive the similar level of sunlight.
Can it be affected by the soil? Soil can be the factor. The plant nurseries are separate, and the plants grow in different soil. The soil quality may affect the plant growth.
Finally, they come up with an idea. It may be related to the nutrition in the soil. Finally, they decided to conduct an experiment.
Iron is one of the components in the soil which is important to plant growth. We assume that iron concentration represents the nutrition level. The higher the iron concentration, the higher the nutrition level contained in the soil. As the iron concentration of soil can be determined by measuring the conductivity of soil. So, the conductivity of soil also refers to the nutrition level. Before the test, the two soil samples are labeled as S1 and S2. S1 is a soil taken from the plant nursery with more plants, while S2 is that of with fewer plants. Pour 250 ml of distilled water into a beaker. Pour 40 ml of S1 into another beaker. Pour the S1 into the beaker containing distilled water. Stir the mixture fully. Pour 250 ml of distilled water into a beaker. Stir the mixture fully. Filter the mixture. Transfer the filtered soil water into a clean beaker. Use a conductivity salinity meter to measure the conductivity and salinity level in the soil water. Wash the detector after use. Repeat the above steps by using S2.
Here is the table showing the results. The salinity of S1 is 2839 ppt, and that of S2 is 520. The conductivity of S1 is 1.5 US per cm, and that of S2 is 0.3. To compare, S1 has both higher salinity and conductivity than that of S2. As we have explained before, salinity is direct proportion with conductivity, and the value of these two scales is based on the ions present in the soil. Therefore, we can simply conclude that S1 has more ions than S2, which represents the clean soil and the dirty soil respectively. The results prove that when the plants grow, ions in the soil has been used. First, this caused a decrease in the salinity of the soil. Therefore, the ions content and concentration are key factors that affect whether the plant's growth is good or not.